Alright, no guts on the iPad. Good. So, alright, today, basically we're moving on into the senses and sense physiology. So it's like a subset of the neurological system. And before we got into all the book stuff, I wanted to begin with the eyeball here, alright? So we're going to focus on one of our several different senses. We got smell, hearing, taste, touch. Each one of them has specific chemical triggers and ways of working. But the eye, well, we could do a macroscopic survey of the organ that supports it. So let's just go through the procedure here really quick. Alright, first, you have the eye. At the front, you have the cornea, which is that frontal part that you have the iris through. The whole white outer part of the eye is the sclera. And then you'll see throughout here we have what looks like muscles. Well, in a human, we have 6 different muscles that will channel left and right turning of the eye, up and down motion of the eye, basically direct, and they work together to view different parts. Alright, but to begin, let's cut all this stuff off. The best way to work on the outside is use the scissors. Now I have the scalpel here because that sclera is pretty hard to cut through. So first I want to trim all this other stuff away. And also, a thing to remember, when you're working with these scissors, the tips cut better than trying to cut the long length of the blade, especially in these little ones. Alright, and when we get to the back, it's kind of hard to visualize, especially since everything around here is white. You have the white optic nerve straight to the back. In fact, I think it's underneath here. Either way. Now, why do you think the optic nerve would be white? Anybody?
Because it's
myelinated. So it runs visual input signals from the retina, which is the back of the eye. And we'll see all that here in a minute. Now, the cutting stuff is pretty simple. Now, I gave you both a video and a little dissection sheet that gave you 2 different ways of cutting the eye in order to do it. So I'll leave that one up to you. You can either do like the professor in the video, where she basically cut all the way around using scissors, she did, and basically bisect the cornea in half, or you can do like the handout and go hemispherically around the sclera. I'm going to do that because that's what I'm comfortable with. Now here's the reason why I even have the scalpel. We want to use the scissors because you have that gelatinous, the vitreous humor on the inside of it. You don't want to just stab in there because when you break the membrane surrounding it, then it just floods. Alright, but cutting through that with just scissors is very hard. Also, jamming the tip of scissors in is practically no different than using the scalpel. So you want to give yourself a good starter cut. Be very careful around your fingers when you do it. Kind of feel it give way. Even then, it's hard. Alright, I see some liquid kind of being liberated. Then, grab your scissors, advance the tip of the scissor in, and try to work with pressure from the bottom up as you cut. Advancing and cutting around. Now, yeah, you'll notice there's liquid kind of coming out. The eyeball is full of liquid, it's full of water and gel matrix too. And just work your way around. And it can be a little tedious as you go, especially as it starts kind of unfurling. When you do a spiral cut around a piece of meat, if you don't have something holding both of those halves that you're cutting, it can get unwieldy. And it's definitely this way when you're cutting something that's as able to be opened is the eyeball. Now, I wasn't really planning for that to happen the way that it was, but we can go ahead and start working on the vitreous humor in the eye then. All right, so look, the best way to talk about light coming through the eye and discuss how you get your sensory input from the world around you is basically to trace the path of light imagery going into the eye. Now, this is the front underneath my fingers here. The rear of the eye, to include the retina, is right here on my left side. Now, light would come up through that lens, come through an iris, which, like we talked about yesterday with sympathetic and parasympathetic control, when you have sympathetic control, it dilates to let more light in. You have muscles on the inside. Well, I'm skipping around a little bit. That light will come through the iris, then it'll hit the lens. The lens is flexible. It's made of malleable tissue, so it has muscles that support it. Again, by sympathetic and parasympathetic nervous control, the muscles can either stretch the lens to make it flatter so you compensate for longer distance view to perceive more threats or anything like that from a distance, or if it's under parasympathetic control, will allow it to become more round, closer focus. We also do voluntary control of it too when we look around and scan. All right, that light will continue through past that lens, through the vitreous humor, which should stay clear in most cases. The lens, you notice it's opaque right now. If this were living tissue and it had all the normal bioregulation that it normally has, that would be a nice clear lens. But when things die or when they get injected with preservative fluids or soaked in them, that'll become cloudy. Anyhow, that light comes through that gelatinous material and finally hits the business end of the eye, as far as I think of it from a neurological perspective. Down here on the back, we have your retina. And this whole very delicate kind of whitish or, you know, like semi-opaque, it's a membrane. It's loaded with rods and cones that pick up sensory input, whether it's color or shape. They get illuminated and excited by the light coming through the eye. Now, it's very delicate. Boxers, people that have head trauma and that kind of thing, you get hit hard enough, this can easily separate from the back of the eye, just like that. Okay? Those are all sheets of nerve cells. Each one of them has an axon that runs from it and comes to a common point. And I'll show you that in a second. But just to show you the union of all these different things in the grand design that you have, this vitreous humor would be exerting positive pressure on this to make sure it stays, kind of like putting a movie screen flat up against the wall, only a tiny version of it in your eyes instead. All right, so all these receptive cells come to a point. And so I'm going to tease this retinal tissue away, and you're going to find that we get to a point where it kind of coalesces and comes together. All right? There are no sensor cells on that point. The axons from them come all the way through, and that's where your optic nerve starts. That's where all that information, about a terabit and a half every second you look around, is coming right through that and going back to the rear portions of your head and getting cognitively processed into shape and things that you can recognize. All right? Right here, you don't pick anything up. So you have left eye and a right eye, correct? You have that binocular vision. Your right eye will compensate for the blind spot in your left eye, and your left eye will compensate for the blind spot in your right eye. All right? Now, you guys notice this kind of reflective backing? This is something we don't have, but sheep, bear, pretty much anything that when you cast light on them at night, you see a reflection from their eyes, like deer when you're riding down the road, or if you're hunting or any of that kind of thing. That's called the tapetum lucidum, all right? And it basically means like tapestry light. Light will penetrate, go through all that retinal tissue and reflect back. So it has like a multiplying effect of light absorption on that back tissue, so it can relay in. That's why these animals can see so much better in the night than we can. So, your major landmarks I wanted you to show. External anatomy, you had the cornea, the sclera wrapping the whole part, and if you can visualize it underneath all this tissue, you have the optic nerve in the back. But you know you can get to it from the front, all right? When you come to the inside, you could dissect out the iris if you want, all right? Basically just working it out with a blunt probe. The vitreous humor, the lens, the retina, which is now a mangled mass of cells, and the tapetum lucidum in the back. All right, anybody have any questions about what you need to figure out? We're going to talk more about the delicate physiology about how light gets absorbed and turned into signals for your brain in later lecture. But today we have the lab and we can go ahead and do this now. So that said, let's get to it. Go ahead and get some gloves and goggles, and pair up, work in partner groups,